Welcome back, everyone. We're going into section 5.1, which is angles and radian measures. So the first thing I want to talk about, angle measures. You have your initial side when you're talking about an angle, and then you have your terminal side. And that would make your degrees or your radians. So from the initial side to the terminal side. I know I've mentioned the word radians a couple times, and you're probably thinking to yourself, what on earth is a radian? So a radian, if you're looking in this circle down here, is whatever the arc length is. So the measure around the circle, that blue part, whatever the arc length is divided by the measure of the radius. So it's the arc length divided by the radius gets you how many radians you're talking about, which would be in terms of an angle. Okay. So the first one says a central angle theta in a circle of radius 12 feet intercepts an arc of length 42 feet. What is the measure? What is the radian measure of theta? So again, we have theta equals S over R as our formula. And that's arc length over a radius. So our arc length was 42 feet and our radius was 12. When we divide those, we get 3.5 radians. 3.5 radians. Now, in terms of our quadrants, one full rotation is 360 degrees, right? 90, 180, 270, 360. Or in terms of radians, it will actually be 2 pi. It will actually be 2 pi. So using that, you can say that pi radians equals 180 degrees because 2 pi is 360. Using that, you can actually convert between radians and degrees. To be honest, radians probably doesn't make much sense to you right now. You're used to working in degrees. So you can toggle them back and forth, right? If I give you radians, you can switch it to degrees, vice versa. So here it says switch each angle in degrees back to radians. So we want to multiply by pi over 180. Now I'm going to simplify, right? 60 and 180 are both divisible by 60. So divide by 60, you get 3. Divide by 60, you get 1. So 1 times pi is pi. And 1 times 3 is 3. So you would say this is pi over 3 radians, or 60 degrees. Again, 270 times pi over 180. I'm going to simplify 270 and 180. Let's see, they're both divisible by 90. So divide by 90, we get 3. Divide by 90, we get 2. So we get 3 times pi is 3 pi. And 1 times 2 is 2. So 3 pi over 2 radians. Or you could have negative degrees, same thing. You get a negative radian. So I'm going to bring this over here a little bit because I'm running out of room. 300 over 1 times pi over 180. 300 and 180 are both divisible by 60. So divide by 60, we get negative 5. Divide by 60, we get 3. And you wind up getting negative 5 pi over 3. All right. Again, 5 pi over 3 radians. You can also go the other way. You can have radians and convert it to degrees. So pi over 4, you just flip it. It would be 180 over pi. So here my pi's cancel out. 4 and 180 are both divisible by 4. So divide by 4, we get 1. Divide by 4, we get 45. And we wind up with 45 degrees. So pi over 4 radians is the equivalent of 45 degrees. Here, negative 4 pi over 3 times 180 over pi. Again, pi's cancel out. Divide by 3, you get 1. Divide by 3, you get 60. And here, negative 4 times 60 gets me negative 240 degrees. So negative 4 pi over 3 radians is the equivalent of negative 240 degrees. Here we've got 6 radians. I'm going to write that as 6 over 1. Again, times 180 over pi. And nothing simplifies here. So you do 6 times 180 is 1080 over pi. And we're actually going to type this in our calculator. You have a pi button. So do 1080 divided by and hit that pi button. And we're going to round this to the nearest 10. 343.8 degrees. So 6 radians is the equivalent of 343.8 degrees. All right, so that's converting radians to degrees, degrees to radians. The next one says draw, so they want you to realize where these are located. To be honest, my advice is to convert it to degrees. You work way better with degrees. We understand degrees. So I would take this and say negative pi over 4 times 180 over pi. And I would cancel and divide by 4. And we get 45. So here we get negative 45 degrees. So in terms of standard position, just means we're starting here and going to 45 degrees. So we want to get to negative 45 degrees. So we're going to start here and we're going to go to negative 45 degrees. So that's negative pi over 4. Next one, 3 pi over 4. Right, again, you're not really used to radians yet, you're used to degrees. So just a quick conversion, right, and you wind up getting that it's 135 degrees. Right, so again, think about where that's located. We're here, 90, and 180 is down here, so we know we have to stop before then. Right, so you're starting in that initial side on the axis all the way around to your terminal side. And again, that's 3 pi over 4. Here, negative 7 pi over 4 times 180 over pi. Again, putting it in terms of degrees. We're getting a lot of the pi over 4s here. So what do we got? Negative 7 times 45 is negative 315. So you're here. Again, negative 90, negative 180, negative 270, and a little bit more is negative 7 pi over 4. All right, so definitely tell me which direction you're going. And then last but not least, 13 pi over 4 times, 180 over pi. And both divisible by 4. So we do 13 times 45. 13 times 45 gets me 585 degrees. That's a couple of rotations here. So we're going to do 585. Well, you know, all the way around is 360. So all the way around is 360. And you still need 225 more. Right, so you're here, you need 225 more. So we're going to go 90 more, 180 more, 225 more. And there's your angle. So you actually have to make a couple of rotations. So you go all the way around as 360. And then a little bit further to get to 585. And again, that is 13 pi over 4. All right. Now, coterminal, this kind of goes with what we just did here. Coterminal means they have the same terminal side. So notice 585 and 225 had the same terminal side. They both end in the same spot. 225 was here and 585 was just one more lap around. So if you're talking in terms of degrees, you can add or subtract 360 degrees as many times as you want, and all those angles are going to end in the same spot, right? Like this one is 45 degrees, right? Negative 45 degrees. You can make another lap around. It's going to end here, and another lap around, it's going to end here. So you can keep adding 360 or subtracting it. If you're talking in terms of radians, one rotation is 2 pi. So again, you can keep adding 2 pi or subtracting 2 pi, and all those will be coterminal angles. So here we're going to say, what do we have? A 400-degree angle. They said find a positive angle less than 360 that is coterminal with each of the following. So we want less than 360. So we're talking in terms of degrees. We're going to say 400 minus 360 as many times as we want, but it looks like we only have to do it once because we get an angle less than 360. Again, positive angle. If you wanted to, you could subtract 360 again, subtract 360 again. They're all going to end in the same spot. So what this is saying is 400 degrees, if you graph it, should have the same terminal side as 40 degrees. They should be in the same spot. It's just one extra lap around. Here, negative 135. Here we want to add 360, right? You can add or subtract 360 as many times as you want. But they said they wanted positive, so we're going to add 360. And we get 225 degrees. So again, 225 degrees and negative 135 should have the same terminal side. In terms of radians, you can add or subtract 2 pi, right? Now, you're going to have to get some common denominators here. Here, if you want a denominator of 5, so 2 pi over 1, multiply 5 top and bottom, you get 10 pi over 5. So for this one, we want to add and subtract 10 pi over 5. Again, you want it less than 2 pi, so we want to subtract here. 13 pi over 5 minus 10 pi over 5. So minus 2 pi equals 3 pi over 5 radians. Next one, see we're negative, we want to add it. So this one's over 15, right? 15, so to get a common denominator, again, 2 pi over 1, we want a common denominator of 15. So it would be 30 pi over 15 is 2 pi. So negative 1 pi plus 30 pi is 29 pi over 15. And again, that is between 0 and 2 pi. That is between 0 and 2 pi here. And then this one's just kind of mixed review here. Find a positive angle less than 360 or 2 pi, so degrees or radians. Here we want to do degrees, so 855 we're going to subtract. So minus 360, what do we get? We get 495. Well, that's not less than 360, so we're going to do it again, minus 360. Again, you can add or subtract however many times you want. We get 135, and we're going to stop there. Here, again, 2 pi is the same as 6 pi over 3. So we're going to subtract 17 pi over 3 minus 6 pi over 3. And you get 11 pi over 3, which is still bigger than 2 pi, so let's subtract it again. Minus another 6 pi over 3. And you get 5 pi over 3. Again, that is less than 2 pi, so we're good. Here, 25 pi over 6, so 2 pi, we want it to be, so we get 12 pi over 6, which is 2 pi. So here we're going to add it. So we got negative 25 pi over 6. We're going to add 12 pi over 6. And we get negative 13 pi over 6. So we need to add another one. And then we get negative pi over 6. So we got to add one more to make it positive. And I'm running out of room, so I'm going to write it up here. So we get 11 pi over 6. So that time we had to add it a couple times, right? We added 12 pi over 6, or we added 2 pi, wasn't good enough. Added another 2 pi, still wasn't good enough. Added a third 2 pi, and then we were good. All right, I'm going to pick up for part 2 on the next one.